All right, welcome, function folks. This is the lesson 3.1, the first lesson of the big trig unit, and this lesson is on radians, whatever that means. And we'll get to that in a second. The 3-minute review here, we were asked to draw the diagram of an angle, and I would be quite satisfied if you just drew a sketch of this angle. But I'm going to use the protractor because it'll remind you what a protractor looks like. Here we put this line along whatever line we'd like to start, and then we think of this line sort of dragging out, and this is the idea of a rotation angle that was new in grade 11. So you know, 20 degrees, 30 degrees, and we can see right there is our rotation angle of 150. And messing around with this a little bit, there we go. And I'm actually going to draw that in so I can get my protractor out of the way. Right, there's the little dot where it's 150 degrees, and then I can draw that, and this angle, this rotation angle here, is 150, right there, 150. So I'm going to call this theta equals 150 degrees. Okay, that's A. State two angles coterminal with theta. So coterminal, what does that mean? It means angles that stop in the same spot. So, you know, I said I've got this one right here. That's 150. What would be another angle that stops at the same spot as 150? Well, I could go all the way around once and then 150. Well, what angle is that? That's going to be 360 is one lap around plus the 150. And whatever that is you have to be patient with me. My computer's acting goofy, and it's running in the it's running pen lines in next to each other. So you gotta be patient. Some of the letters are gonna look weird. So anyway, what is this? This looks like it's 510 degrees. And one thing, I could just add another 360, right? 2 laps around, and then 150. What's that? That's 870. That one works. Notice I could, and this is kind of a reminder of what a rotation angle is all about, is I could go the opposite way. I could go this way. When I go the opposite way, which is clockwise, that's a negative angle. So what negative angle is that? That's 90, 180, and that little bit there is, well, what is that little bit? Oh, hang on, we missed A. I'll have to go back and I'll talk about what that little bit is, but that's 180 and 30. So negative, we could also just say it's negative 180 and 30 is 210. And notice, just in case you were interested, I could take my 150 and subtract 360 and get that same very angle, that negative 210. By the way, there's a word for this angle 150 that's between 0 and 360. If it's between 0 to 360, we call that a principal angle. Principal angle. Not like Mr. Ritzma principal angle. Now, back to A is actually the related acute angle. Related acute angle is this little bit in here. Well, if this is 180, we know a straight line is 180. This is 150. This is 30. And as we learned in grade 11, what's so important about coterminal angles? Coterminal angles all have the same trig ratios. So the sine of all these things is the same, the cos of all these things is the same, and so on. What's the deal with the related acute angle? Well, remember from grade 11, we had relationships between angles that had the same related acute angle. And the related acute angle, remember, always goes down to the x axis. So a related acute angle that would have 30 in this quadrant would be down here. And part C, by the way, is a little bit of hassle, but we'll go over this more soon. The idea here, cos of 150, tan of 150, cosecant, basically we can build a little triangle. And in grade 11, we learned what the relationship between these sides were, right? And if hopefully you remember, the opposite one was the smallest one was 1. The adjacent was the square root of 3. And I said, oh, I don't remember this. Don't worry, we will review all of this stuff. And in fact, I'll have my own special way that I remember it. And from here, then, we can sort of decide, well, which of these coordinates is negative? Since this one's to the left, this one's negative, that one's positive because it's up, and we always think of the hypotenuse as being positive, so we don't think of this as being ever negative. It's always positive. And then the cos of 150 then is still just good old grade 10 definitions, the old SOHCAHTOA. See, there's the pen going weird on me, so you're gonna have to be patient about that. I don't know what's, I'm gonna have to restart my computer or some darn thing. Cos is adjacent over hypotenuse, and there's the related acute angle. The adjacent side is negative square root of 3. The hypotenuse is 2, and there's that value exact. And again, we'll spend quite some time going over these exact angles again. This is a little bit of a review that we will review more. Tan of 150 is the opposite over the adjacent. Opposite over adjacent is 1 over 2. Both of them positive. Oh, no, hang on. 1 over, excuse me, opposite over adjacent is 1 over negative square root of 3. Dandy. And last, cosecant. SCS. I can't remember which one goes with which. We will review all this stuff. Will become like second nature to us, folks. But cosecant, remember, is one of the reciprocal functions, and its reciprocal is sine. The way I like to remember it is there's a CS pair for each one. Cosecant goes with sine, cosine goes with secant, and those are a pair. So how am I going to do this? Well, I can state the sine of 150. The sine of 150 is opposite over hypotenuse, 1/2, 1 over 2. So therefore, the cosecant of 150 is the reciprocal. Just flip it, right? Because they're reciprocals of each other. 2 over 1 or just 2. And again, all this stuff will become more clear soon. What's the new, this is supposed to be a therefore that got messed up with my computer's glitching. It's glitching out on me. Today's lesson is on something called radians, and I introduce you to this idea of radians by telling you a little story. So the story starts with I ask a student in class, student, how much does a CD cost? And the student says, well, it costs about $10 these days. And fine, okay, so that's $10. But I go south of the border. I go over to Buffalo. And I ask a student there, student, how much does a CD cost? And they say $9. And then, next thing you know, I'm on a plane and I'm asking somebody in Germany. German student, please tell me, how much does a CD cost? And the German student says in German, but I'm translating for you here, 4. And then I get back on my plane and I go ask a Japanese student, how much does a CD cost in your country? And they say $16.30. And then in Mexico, I'm a world traveler over here. In Mexico, it was $160. In Italy, they said it was 23,000. Why all these different answers? Well, of course, and it's a bit silly. I realize that, but they are in different currencies, right? The German, and in fact Italians now, but the Germans deal in euros, right? So 4 euros for a CD. Japanese, this is in yen. This is in Mexican pesos. And the Italian one, even though in Italy they use euros now as well, this would be the old style of Italian currency, which is called lira. Well, what's going on here? Why are we telling this story about CDs and prices in different currencies? Well, there are different currencies for angles, and the angle currency that we're used to is degrees. And the thing is about degrees isn't very mathematical at all, right? We know in a circle there's 360 degrees in a circle, and that kind of defines how much, what our protractor's about. All the way around is 360, so a protractor's got 180. Have you ever wondered to yourself, why is it 360? Why isn't it 100 degrees in a circle, or 10, or 17, or 4,000, or 23,000? Why 360? Well, that's a good question. It's not very mathematical answer. Basically, when math started out, they thought that it took 360 days for the Earth to go around the sun. So they thought, well, let's call the number of degrees 360 around in a circle, and then we could say 1 degree is how much the Earth goes around the sun in 1 day. Well, we know it's not 360, and in fact it's not 365, it's 364 and some fraction, and it's just not a very mathematical measure, degrees. And I'm going to tell you all about the more mathematical measure, which is radian measure, in part 2.